Hello everyone, I'm Tim and I have a problem with this plant. Stop, before you go now, no, I'm not the plant guy who's going to tell you about green stuff. It's just that this thing is growing and growing, maybe because I fertilize it, and it has now developed a tendency to throw itself off this table here. So something needs to be done to keep it growing up to the ceiling. As you can see, it is only held by this hook that I printed as a quick emergency solution, and it is really very close to tipping over. So I need a bigger pot, which will of course be 3D printed, more on that later. The problem is, how the hell can I get this big plant from the small pot into a bigger one in the easiest way possible? I mean, it would certainly work somehow, but I want to be able to align the plant properly in the new pot so that it stands up straight and I can free the roots from the soil to replace it. This is probably where the more interesting part for you comes in. So I've come up with this lifting device with which I can, in theory, simply lift the plant and hold it in the air so that I can then hopefully carry out my work down below in the easiest manner. The plant grows up these 3 climbing rods which I've connected with these printed parts. I will attach this apparatus to my kitchen table and lift the plant with these 2 hooks on the connectors to free it from its old pot and then position it exactly in the new one. Once the work on the plant lifter was complete, I could start printing. Before we continue, a quick word about the sponsor of today's video, PCBWay. PCBWay offers you a service that turns your hardware ideas into reality, be it printed circuit boards assembled on request, CNC milled parts, laser cut steel sheets, 3D printed parts made of plastic or metal, injection molded parts and much more. At PCBWay you get everything from a single source. Simply upload your file in the configurator, select the production process, the finish, quantity and many other options and receive your individual quote. PCBWay will take care of the rest and the parts will arrive in your mailbox shortly afterwards. Check out the first link in the video description to have your own parts made. Many thanks to PCBWay for sponsoring this video. Okay, what does it take? 833. Okay. 833 should be here. Let's start. It should be ready now. Oh, come on. Oh, looks nice. Just kidding, of course I used a real 3D printer. I printed the parts from PLA, which is perfectly adequate for this purpose as it is cheap and can be recycled. Before I can assemble the parts, a few heat inserts have to be melted in. I decided to use M4 screws, which are much stronger than they actually need to be, but somehow I usually just go for the side that looks right. Theoretically, even M2 would probably be enough, especially if, like me, you use more screws than are absolutely necessary. Do you also choose the screw diameter for such relatively unimportant parts simply by feel? By the way, I've uploaded the files for this lift, including the source files, to my printables profile. So if you have a use for this lifter, you can easily adapt the design to your needs. You will find a link to it in the video description. However, once the heat inserts were in and the threaded rods cut to length, I was able to assemble the lifting device. The rail consists of 3 individual parts which are screwed together with these 2 M6 threaded rods. It is 60 cm long in total, so I can lift the plant by about 40 cm, which will hopefully be enough. The guide rail will not be exactly vertical, by the way. It is tilted back by 3 degrees as the part will certainly have some flexibility and it would not hurt if the climbing rod is tilted slightly backwards. The weight of the plant will pull it forward anyway. Of course my washers were a bit too big and so I couldn't get the sled onto it, but at least I now have an end stop so that the sled can slide out on its own. You're probably asking yourself now, why is there a gear? Well, at first I had the plan to lift the plant using a crank. So I made the cogwheel and the matching rack, and only then did I realize that this was completely unnecessary, as I need a locking mechanism anyway, and I could simply lift the plant to the required height by hand. Since removing this gear was too much work for me, I just left it there and made the 2 clips for easy locking. One clip will probably be enough. I only added the second one because I had the space for it. In hindsight, I realized that I probably won't be able to reach the second clip anyway if the plant is hanging on the lifter. Now all that's missing is the pot. I've already designed several plant pots, and this one is by far the largest yet. I don't want to have to repot this plant in a year or two, so the best way seemed to be to make full use of the print bed of my XL. On the inside I have created this structure. My plan is to fill the lower part of the pot with gravel up to the maximum water level of the coaster. On the one hand, this provides some additional weight, and on the other hand, it reduces the risk of the soil and organic material starting to rot if water remains in the pot for longer. But the structure itself is only there so that I don't have to use quite so much gravel. So it doesn't add that much extra weight, it's probably not necessary anyway. Over time, roots will also grow into the gravel, which can then absorb the remaining water from below. In principle, this is similar to a self-watering system where the roots adapt to the direct contact with water. At least that's my theory. The pot is 355mm in X and Y and 320mm high. I also wanted to have a coaster that couldn't be any bigger due to the build space of my printer. Nevertheless, I want to be able to see if there's water at the bottom and, if necessary, fill it in there directly. For this reason, there are these large cutouts in the pot on all 4 sides. There are holes and channels on the underside so that water cannot accumulate anywhere. After the 2 parts were printed, I removed the supports to expose the channels and drilled holes where the structure is on the other side, so that water that collects in them can drain away. In total, I needed over 2 kilograms of filament for the pot and tray. Not exactly cheap for a plant pot, but at least I have my own design. Speaking of the design, this look with these facets running to 0 on different sides somehow looked better in Fusion. I thought it would give a nice effect with light and shadow, but it didn't quite convince me in retrospect. What do you think? As I didn't want to waste too much material on the coaster, I printed it with just 2 wall lines and then sealed it with Stichtol. This is a stuff that can seal small holes in prints, which normal varnish can't do. So I went into the garden, as the stuff contains quite a lot of solvent and I wasn't in the mood for that kind of intoxication. With the warm weather, the sun and a bit of wind, I really had to hurry with the application, which is why the large surface turned out so uneven. I just wasn't quick enough with the brush. After that, I quickly watered the plants in the garden, and this little bird thought it had to slaughter a cricket right next to me. I then left the plate to dry overnight and filled it with water the next day to test whether the coaster was really watertight. While hoping that the saucer wasn't leaking water, I took the opportunity to do a little side project. Nicholas from 3D-Mind, a small shop on Etsy, sent me a retrofittable USB socket for my Prusa XL. This is simply connected to the power supply and replaces the standard cover that is installed there from the factory. The small circuit board was developed by Nicholas himself and came in very handy for me, as I bought the Buddy 3D camera for the XL a few weeks earlier. Unfortunately, the printer itself doesn't have a free USB port to which the camera can be connected directly, so a USB power supply and a free socket are required. He simply sent me the part for a small post on social media, but since the part is so valuable to me and he is really nice, I wanted to show it to you here. I will leave a link to his Etsy shop in the video description. A few hours later, the table underneath was still dry, so I could be sure that my floor would remain dry even if water were to stand there for a long time. Somehow it was a bit stupid not to do this test in the kitchen next to the sink, so I had to scoop out the water with this plastic tray until it was safe enough for transport to the sink, which by the way was still quite a balancing act given the size of the saucer. Then I also quickly created the sleeve so that the soil wouldn't stick to the pot itself so much. I thought that might come in handy if I had to get the plant out of there for some reason. As I found out, prints with such large surfaces became quite wavy in vase mode, so I then tried to smooth the surfaces a little with a heat gun, which worked okayish. The surface is a bit wrinkled now, but it is much smoother than before and no one will see it later anyway. At this point, everything is ready for the real action, but before we get to that, I would like to say a few words about this channel and what you will see here in the future. This is only my second video on the channel and as I said, it's not going to be about plants. It was just necessary and I thought I could just make a video out of it. And yes, a lot of time has passed since the last video. I hope I'll be able to upload videos more often in the future. Speaking of the future, I will show you all kinds of projects that involve 3D printing in some way. I already have a whole list of cool ideas and have already started working on the next project. Without wanting to spoil anything, I'll just say that it has something to do with this table here and these ball bearings. I don't know, can you see them? These ball bearings. And it's probably something that some of you will want to replicate. I haven't seen anything like this before and I can't wait to upgrade my printer table with this. I think this will be really nice. If you have an idea what it could be, feel free to share it in the comments. I'm curious to see if anyone can guess what it might be. So I can only recommend that you don't miss this and would be very happy if you subscribe to my channel. As said, my second video, if you haven't seen the first one yet, be sure to watch it next. But now back to the actual topic. Repotting was pretty straightforward, almost. Oh Gott. Shit. Oh nee. Oh nee. I wanted to do it in the kitchen where there is enough space, but I quickly realized that I couldn't get the plant through the door without damaging it. So back it went to its place and the kitchen table into the living room. I attached the lifter to the table with a clamp and the whole thing was less flexible than I had expected. Nice. Just hanging there. It's not on the floor. Now I should just... Yes. What's it hold itself through friction. Okay. Well, that's a nice feature. So I don't even need these clips. Maybe I should use them for safety reasons. Okay. As expected, the second clip was completely unnecessary and so I was able to remove the plant from the pot and the old soil. The latter took some time as it was intertwined with a lot of roots. As you can see, the difference in size between the old and new pot is pretty huge. Normally you don't make the new pot much bigger than the old one, because otherwise the plant will spend quite some time getting root in the new pot and won't grow much during that time. But like I said, I don't feel like repotting it again in a year. I want this to be the last pot for this plant. Next I filled the bottom with gravel and then filled the rest with a very airy mix of soil, coconut chips, pine bark and other stuff. By the way, one of the main reasons your plants die at some point is that the soil is too compact and therefore never dries out properly in the core, which means that the roots always remain moist and eventually start to rot. An airy mixture like this ensures that the roots get enough oxygen to prevent this from happening. Of course, I didn't have enough soil, so I can only fill up the rest when I have some more. Once the monstera has grown to the ceiling, this ugly IKEA table will be removed and it will stand directly on the floor. Since the plant is still very unstable in its new pot, I have secured the climbing rod to the wall with a piece of string until the soil has settled and the roots have grown through the large pot. And that already brings us to the end of this video. If you want to print the pot or the lifter yourself, you can download these files for free on my printables profile. The pot should be easy to scale, as surely not everyone needs this size. You can find the links in the video description. And one quick note, I'll be at the Maker Fair Hannover in Germany on August 23rd and 24th, so in a few days already. Together with a few others like 24/7 Printing, Jantek, Meister Edel and Mpox, we'll have a large booth in the Niedersachsen Hall and we'll be showing lots of 3D printing stuff. So if you happen to be in the area, be sure to stop by. That's all from me for now. If you enjoyed the video, make sure to give it a like and subscribe to my channel. I'm already working on the next project and hopefully it won't take as long until the next video. We'll see. Until then, take care, bye. How the hell can I get this big plant? Why?